Hey, good morning, everybody. This is Mr. Aynesworth, and we're in 7.4 lesson part 3 now in a series of lessons going over how to graph the tangent and cotangent functions and basically all the reciprocal functions, okay? In the first lesson, I worked on the tangent function, part 1. Part 2 is a cotangent function, and now we're in part 3 and talk about the secant function, which is reciprocal of cosine. All right, so why does it behave the way it does? Why does it look the way it is? Why does it have a different range and so on? So we're going to get into that. And so the first thing we're going to do, though, to kind of understand what's going on with this reciprocal function is analyze some x-coordinates on the unit circle that represent the cosine of theta. Okay, so you know on the unit circle that x equals, the x-coordinate equals the cosine of theta of that angle. You know that. So if you zoom in here and look at your unit circle here, I'm talking about these x-coordinates here from 0 to 90 degrees, like 1/2 and root 2 over 2 and root 3 over 2. Those are the x-coordinates here. Okay, I'm concerned with those now. And what we're going to do is we'll reciprocate them and see what happens. Now, first of all, we're on the radius unit circle here. And because of that, we have a radius 1 circle. So hopefully it's obvious that all of these x-coordinates are less than 1. Remember the range for cosine, all right, is from -1 to 1, which means all of these numbers fall in here, in this interval, okay? They're definitely less than 1, so hopefully you accept that. But what happens when you reciprocate these numbers? What kind of numbers do you get? Okay, so we're going to write these numbers down here first. We've got to work with 1/2. And the next one, root 2 over 2. Let's go in order, root 2 over 2. And the third one here is going to be rad 3 over 2. Rad 3 over 2. And all of these numbers, and a little note here, are less than 1. Okay, so all of these numbers, because they're in the range of cosine, are less than 1. So hopefully you accept that. What happens when you reciprocate a number less than 1? So we're going to take the reciprocal of each one. All right. And what do we get? Okay, so here we go. All right, we're starting with 1/2 here. Take the reciprocal. The reciprocal of 1/2 is obviously 2. All right. And then the reciprocal, what's the reciprocal of 2 over rad 2? What is that? Okay, so the reciprocal here is 2 divided by rad 2. Then you rationalize. Right here, you rationalize it, so multiply it by rad 2 over 2, rad 2 over root 2. And then you get 2 rad 2 divided by rad 4, which is 2. That simplifies to rad 2. And you guys should know that's about 1.4, okay? And then the next one here, what happens when you take the reciprocal of root 3 over 2? Well, you get 2 divided by rad 3. And then if you, well, let me see, probably wouldn't help you to rationalize this. So just use your calculator here, and then trust me, or just use your Desmos right here. It is about 1.15, okay? 1.15. And notice that all of these reciprocals that I'm talking about right through here, okay? I go in backwards order here. Oh, that's okay. All right, so all of these numbers here are greater than 1, okay? 2 is obviously greater than 1. 1.4 is greater than 1, and 1.15 is greater than 1 right here. And so if you go from 0 to 90 degrees, so it's supposed to start off with root 3, so let me see. So starting here and going through this way from 0 degrees right here to 90 degrees right here, and you take the x-coordinates as you do that, look what happens to the numbers. We get 1.15, and then we get 1.4, and then we get 2, and all of these numbers are out of the range of cosine. They're all greater than 1, okay? All of these ratios. So when you reciprocate a number less than 1, you always get a number bigger than 1, okay? So the reciprocal, and here's our main finale here, all right? The reciprocal, okay, of a number less than 1, okay, is always, big word here, is always greater than 1, okay? This is the greater than symbol here, greater than 1. There we go. And that is an integral part of understanding the secant function, as well as the cosecant function that is too. All right, so now let's get into the function itself and I'll apply what I just went over there. That was just a little mental numerical warm-up here so you can understand what's going on with the secant function, okay? Now we have to start off with the domain like I did with all the other functions, okay? So what we need to do is analyze and redefine the secant function. So the secant of theta, as you guys know, is a reciprocal of cosine, so 1 over cosine theta. And this is a rational function, so we need to figure out what restrictions are needed here because the domain is all reals except something, right? So you have to remember the basic concept that I've been talking about in all my lessons. All right, you cannot divide by 0. So I'm going to write it down again just to make a point. You cannot divide by 0. Okay, because of that, all right, cosine of theta, all right, can't be equal to 0. And that implies that theta cannot be equal to pi halves, 3 pi halves. I'm talking about the top and the bottom of the unit circle here. And then 5 pi halves, etc. And the way we write that is theta cannot be equal to pi halves, all right, plus k pi, plus multiples of pi. So plus k pi, where k is, some integer. Okay, I'm talking about 0, plus or minus 1, plus or minus 2, plus or minus 3, etc. Okay? So why is it pi? Well, if you add pi halves to plus pi, you get 3 halves pi. You add pi again, you get 5 halves pi. So you keep adding multiples of pi. So k pi is it's a fancy way of saying multiples of pi. Okay, that's it. Nothing fancy there. Okay, so that is the domain. Okay, and it also gives you information on, as I keep saying in all my videos, the vertical asymptotes. Okay, if the function's undefined there, well, guess what? You got to have a vertical asymptote there. Okay, so we start drawing those first when we start graphing, and then we plot some points, and we got to figure out where it is. All right, so let's plot the asymptotes first. So negative pi halves first. Remember, k can be negative as well. Okay, so our first asymptote is at negative pi halves, and then positive pi halves, and then 3 halves pi. You know the drill. Okay, we do this in every single lesson here. So these are all vertical asymptotes right through here at these angles right here. So it's all reals except these, right? That's why we always analyze the domain first, right? Because then we know exactly where the asymptotes are. Okay, and then to figure out where this function lives, okay, we're going to plot some points. Okay, so let's evaluate the function first. Okay, so here we go. So we're going to take the secant now of negative pi halves. Now, so where's the unit circle here? So let's kick in the unit circle a little bit here. The cosine of negative pi halves. Now, negative pi halves, that rotation is clockwise, and that puts you down here at 3 pi halves. It's coterminal. And so notice that it's 0, negative 1, and cosine, we know that cosine of 3 pi halves, okay, is 0 there, all right? Ooh, it's 0, so the reciprocal of that is 0 divided by negative 1, and the reciprocal of 0 is undefined, okay? So there, right there, 1, it's 1 divided by 0. Okay, let me rewrite it here. Let me write it like this. So 1 divided by cosine of negative pi halves. Okay, that's equal to 1 divided by 0. And as you guys know, this is undefined. Okay, and that's why we have vertical asymptote. So you can understand vertical asymptotes by looking at the domain. You could also find them by actually just evaluating the function. Wherever it's undefined becomes a vertical asymptote. There we go. That's why the first one is at negative pi halves. Okay, so what do we get at negative pi fourths? Well, let's find out. So secant of negative pi fourths. Okie dokie. So if we knew what the cosine of negative pi fourths was, so cosine of negative pi fourths, that's quadrant 4, okay, because remember, negative angles are a clockwise rotation. So that's coterminal with 7 pi fourths. and the cosine value there is root 2 over 2. So it's root 2 over 2. So the secant of that is a reciprocal of that, which is 2 over rad 2. All right, so this is equal to 2 divided by rad 2. All right, and we did that earlier. Let me see. I did that earlier. Look up top of the screen. That's equal to rad 2, okay, which is 1.4. And notice that it's greater than 1. Holy cow, this is out of the range of cosine. It's greater than 1. Whew. Okay, so now secant of 0, that's equal to 1 over cosine of 0. 1 over cosine of 0, which is 1. 1 divided by 1 is typically 1, especially today. All right, next one. So we have secant of pi fourths. Well, I know that cosine of pi fourths is rad 2 over 2. And I just did that up top, right? And so that's going to be positive 1.4. Okay, so these two are related right through here. And then here, secant of pi halves. That's 1 over cosine of pi halves. Okay, guess what? That's 1 divided by 0, and that's undefined. Okay, so you have to be able to evaluate functions in order to understand really what's going on. That's why I'm doing this here. So I just found another asymptote at pi halves. Okay, so now let's plot a few points. Okay, now it says up here, graph cosine first. Okay, so I'm going to do that in a different color. So I'm going to do that in green. Woo. Let me change something here. Okay, so I'm going to graph cosine in green here first. I'm going to stop and do that first. Watch what happens. So you guys are really good at cosine. So cosine of 0 is 1, cosine of pi halves is 0, cosine of pi is negative 1, and then cosine of 3 halves pi is 0, and then cosine of 2 pi is 1. I'm going to back. I'm going to go cosine of negative pi halves is 0 here. So here's cosine. You guys are good at this. We've done so many masters on this. You guys, we had 2 separate masters on this. So you guys should be able to graph this in your sleep. Okay, so there's the cosine function right there. Now, why would I have you graph cosine? It's to help you understand what's going on. Now, as you guys know, cosine's range right here is negative 1 to 1. Okay, the minimum is negative 1. The maximum is 1. This is the range of cosine. And notice that we have values of secant that are outside that range, that are greater than 1 and then, greater than 1 in this example. Okay, so when you graph this function, right, so now I'm going to talk about the secant function. I'm going to put the secant function in blue. Okay, it has to live between these dotted lines, right? And so at negative pi fourths, I go right negative pi fourths and up 1.4. Which is why I gave you guys the scale of this right here. So this is 1.2, all right, 1.4 right here. So I go up 1.4 units. Okay, between the grid lines, there's 5 grid lines between, or 5 units between 1 and 2. So each one is 2/10, okay? Hopefully you guys follow that. So again, 1.6, 1.8, 2, okay? So you plot that point. And then secant of 0 is 1, so it goes right through the max here. So it goes through the max. Okay, and then at pi fourths, you get 1.4 again, so it's here. So basically, secant kind of looks like this. Now, it's not, that's kind of shaky here. Should be more like this. There we go. All right, so we're gonna graph this in Desmos here so you can see what the secant function looks like. And notice that's at the top of the cosine graph. It hits the max right there, but goes infinitely up. So why does it go infinitely up to infinity as you go from 0 to negative pi halves? Or if you go from 0 to pi halves this way, why does it go to infinity? Why does it go up? Well, think about what we just did earlier with all these crazy numbers, okay? When we took a look at the numbers and we reciprocated all the x values from 0 to 90 degrees right here, notice what happened. We got 1.5, 1.4, and 2. Okay, the reciprocals got bigger and bigger and bigger, and that's what happens when you take a look at this graph here. Let's look in from 0 degrees into 90 degrees. Okay, so in this interval right here, you take any value on the graph. You take this value really, really close to pi halves at point A, okay? let's say it's 2/10. Okay, so let's say it is, well, it is 2/10. Okay, this is 0.2 right here. So 2/10 is equal to 2/10 is equal to 1/5. And you take the reciprocal of that, and guess what? You get 5. And that's way up there. All right. The reciprocal of 1/5 is 5, and that's why this graph goes sky high. All right. It goes sky high. Now, if you get even closer, let's say this point right here at B, let's say it's 1/10 away. All right. So that's obviously 0.1. Now, 0.1 is 1/10, and the reciprocal of that, R stands for reciprocal, is 10. And so if you take a reciprocal of any of these points on the cosine graph, which are numbers less than 1, right? They're really small. And you take a reciprocal of a really small number, you get a really, really big number. And that's why the secant graph goes up and approaches these vertical lines called asymptotes. And that is why the function here behaves the way it does, because the reciprocal of a number less than 1 becomes greater than 1. All right, so a little number theory there. All right. Now, what you're going to do is, to understand this, it also lives in this next interval here, but these values are going to be negative right through here, and the graph's going to live down here. And we're going to go to Desmos here and verify that. Okay, and then the third interval, it approaches these vertical asymptotes here. So one period of the secant function is from negative pi halves to 3 pi halves, which is 2 pi. So the period here, well, it might be easier to see here. So the period between, the distance between negative pi halves and pi halves, well, I guess that's pi. And then this is another pi radians here. And so the distance, okay, is 2 pi radians. So there's your period. Period is equal to 2 pi. It repeats this cycle, this piece in between negative pi halves and pi halves that's going up, and in this next interval, the period or the piece that's going down, that will repeat infinitely. And I'll go to Desmos here in a minute. The domain, as we talked about earlier, okay, is all reals, okay, not equal to pi halves plus k pi, or you can just list out the angles if you like, where k is some integer. All right, and then the range, okay, well, it's different. Okay, so the range, okay, so now take a look at this. Go back to the graph here. All of these y values are greater than or equal to 1 if it's above the max. And then the range down here, it goes down. The range, or all these y values here, are less than or equal to -1. So there's a couple different ways you can write the range. One way is to say, okay, y is less than or equal to -1, or y is greater than or equal to 1. The other way you can write it is using intervals. So from negative infinity to -1, make sure it's closed, or from 1 to infinity. So it's half open, half closed. All right, and there we go. So now the only thing we need to do is validate everything I said. So let's go to Desmos here, and let's validate the graph. So turn off your previous colors. All right, if you haven't put your functions in, well, obviously you need to do that. So I'm going to expand the graph just so you can see things better. Okay, there's cosine and there's secant right through there. And the asymptotes, I need some asymptotes here. So I need the right asymptotes. There we go. I need 3 pi halves. Where'd 3 pi halves go? There we go. So there are my asymptotes. Okay, so you'll notice that at the max here and the min, and if you want to look at more repetitive periods, look at this. This thing just keeps on repeating. Okay, so there you go. And again, the reason why we draw the cosine curve is to help us guide and draw the secant curve. Okay, so you'll notice that all teachers probably do that. Okay, so draw your asymptotes first, sketch your cosine curve first, and then the secant curve will always appear at the max and the min in a repetitive cycle. Okay, so let's screenshot this, and let's bring this into our lesson here, and you can add that on your own. And then I will see you in my next lesson here when we talk about the cosecant function in part 4. All right, this is Mr. Aynesworth. I'll see you next time. See ya. Bye-bye.